Hello and welcome to Wildly Curious, a podcast that tells you everything you need to know about nature and probably more than you wanted to know. I'm Laura.
And I'm Katy, and today we're going to be talking about how animals, plants, and fungi, and even some bacteria have all developed ways to produce light on their own, aka bioluminescence.
I'm pretty excited about this one. We were going to do this last week for Halloween, but then I was away at a conference and we could not figure out how something wasn't working.
Yeah, you get a good process down and then you change one thing.
And you're screwed.
And then boom, yeah.
It wouldn't let me record from where I was. So, oh well, you guys got caves. And now this week's bioluminescence.
Oh no, you guys got caves. Well, I do want to say that we did miss a fantastic opportunity. Did you know that October was Squirrel Awareness Month?
I did. My neighbor, who is a new podcast, very avid listener, shout out to Robin, she immediately texted me at the beginning of October going, did you know it's Squirrel Appreciation Month? Because her students were writing prompts about it and everything.
My boyfriend, he shot me a text because he has a thing with squirrels. So he did a project in undergrad with squirrels where he was basically before they had Ring cameras. He made a camera and stuff. This is back in the early 1800s because he's that old. No, I'm kidding. He's not that. He's not that old.
Ring cameras in the 1800s.
Yeah, no. For squirrel boxes to watch their mating patterns with the biology department. That's not how he described it, though. It was squirrel. Boop.
Now we're going to have to tag this episode as being explicit because of that word choice. Gosh dang it, Katy. We didn't even get into the content.
Squirrel. Boop. Hopefully, I'll go back and bleep it out. Goodness. But we missed an opportunity there to either talk to him about his squirrel. Boop. Or just or splooting, to revisit the splooting.
Yeah.
Which is one of my favorite.
I know. I think about that every time I see a squirrel laying down. I'm like, oh, look, it's splooting.
Yeah, look at him splooting over there. He's just splooting away, doing what squirrels do. Just loving life and splooting.
Mine isn't really nature news, but I'm done listening to an audiobook series I've been listening to for the past 6 months. So I'm like, now what do I do with my life? So now I'm listening to podcast episodes again. And I just listened to, it was recommended to me. It's called PBD Podcast. And I don't know about the rest of the podcast. I only listened to this one episode that was recommended to me. But it's called We're Not Alone. Louis Elizondo, Real UFO Encounters, Government Secrets, and Underwater Aliens. I mean, if that's not an intriguing title, right? I don't know what it is. But it was really good. It's Louis Elizondo is a former U.S. military intelligence official who leads the ATIP program, or who did lead the ATIP program through the Pentagon, which is the Aerospace Threat Identification Program. And he talks all about like UFOs and UAPs, which is the newer term for it, and was exploding my mind because I
just like how they rebranded aliens.
Yeah, but we're going to bring up every few episodes, BT dubs, there's aliens. BT dubs, there's aliens. Like between you and I, we're just going to keep bringing it up because it was said during COVID, right? There are aliens, and everybody just let that one go. But there's a lot of good content to it. But my favorite part that I've never thought about before was he was like, so aliens. And Lou was like, okay, but let's stop right there and talk about this because aliens, I feel like everybody thinks about as being extraterrestrials. Okay. But that's not necessarily what alien could be. Aliens just mean not us, not human technology like stuff. So could be dwelling in the ocean, since we have less of the ocean's map than we do outer space.
We have no clue.
Another dimension. They could be interdimensional travelers. We have no idea. Like, that's how much we don't know. It doesn't have to just be like dudes from out on another planet. Could be
tiny
this
green men,
planet, which I've never thought about before, and was what if they are from the oceans, or what if they are just from another dimension? What if they've been here all along and only now do we have the technology to be able to see what's always been here?
And that's what a lot of people are saying. And if you look back through or there's a lot of people that will show like evidence through, aliens and UFOs and stuff like that throughout history. And that's what they say, like they've always been around. And but I mean, I was a huge X-Files junkie as a kid, and I went through that whole phase in middle school where I was like X-Files everything. So
I mean, it was just a Men in Black discussion. The whole thing was like,
essentially.
Men in Black is real. Always has been, guys.
Yeah. Well, I have some nature news too, and I thought this was pretty cool. We're going to talk about bats for a second.
Okay, because it was Bat Appreciation Month this last month too.
Absolutely love bats. But researchers, they recently discovered that bats, through their poop, are providing scientists with a surprisingly detailed history of regional fires. So bat guano previously to this is a new study that was published. Researchers have analyzed bat guano to infer past climate and vegetation changes. There was a huge study published in 21 recently that examined 4,300-year-old bat guano deposits in Jamaica to understand the history of dietary shifts and environmental conditions through then. So this one is just then looking at bat guano to look at the history of wildfires. Thanks to tiny bits of charcoal that get stuck to their fur, they fly through the smoky areas and brush against charred plants. I mean, it makes sense. When bats groom.
Okay.
Say again?
I was just going to say, so when they groom, I guess it gets in there?
Yep. So when they groom and do their business in caves, the charcoal particles settle into, obviously, the layers and layers of guano. A team tested this theory by analyzing a 2-meter-long guano core, which...
Didn't know it was a thing until right now. Yeah.
Right, guano core from a Tennessee cave dating back to the 1950s. And they found that charcoal bits and bat poop lined up perfectly with records of local fires, making guano an unexpected but valuable tool for tracking historical blazes, which is pretty neat, I thought.
That is cool. And that also sounds like a new genre of music. Guano core.
I was like, a new thing of music. What?
You're like, well, then I was gonna say it faster, but then I sneeze.
Then he sneezed.
New genre of music. I should have let you go first, because then there could have been the transition from the ocean to the bioluminescence. But now, alas, I can't connect it to bats because bats don't bioluminesce, at least yet.
God, that would be amazing if they did, though. Could you freaking imagine?
Right? Little guys flying through the air, just little beacons of light.
I could not love bats anymore until
they bioluminesce.
Then I would love them even more.
Then a little bit more. Like Katie said earlier, we're talking about bioluminescence. So it's my job to tell you guys what that is and how does it work. And then Katie and I are both going to take a section of why do they bioluminesce.
So I'm going to talk about offense, defense, and then Laura, you're talking about communication, right?
Yes.
Yep.
All right. So first of all, what is bioluminescence? Well, according to the National Oceanic Administration, who's the ocean people, and most bioluminescence happens there, so they're the experts. It's the production and emission of light by a living organism. Okay. So it is not the same as biofluorescence, which is when an organism absorbs light from an external source and then re-emits it at a lower wavelength. So think about glow-in-the-dark paint, right? You need light to make light. Bioluminescence is the organism makes its own light. So it seems to have evolved 40 different times over the millennia, like by itself. So it's not like one thing from one thing. We're just talking like randomly. It was like, what would be better if we glowed?
Yeah. You know what I should do right now? Light up. I feel like I should light up.
Light it up! Mostly 80% of things that do this are aquatic, but 20% are on the land. These organisms can be found all over the world as not just a regional thing. And there are about 1,500 species that do it. From fungi to protists to bacteria to invertebrates to fish. Nothing higher up. So far, no reptiles, birds, amphibians, or mammals, which is a bummer. So we're not quite to Avatar yet.
Wait. Say that again.
So nothing higher than the order of fish.
Okay. I was like, hold up a second. Because I have some examples.
Yeah, on the evolutionary tree, nothing higher than a fish. Or anything below that. But yeah, we're really missing out here on the mammal and the bird, and I guess
once again, humans. Yeah. We missed something really
it'll
cool.
make more sense later when Katie and I talk about the reasons for it. We're talking about a lot of stuff that can't talk or make sound to do this. But I feel like it'd be better if we could.
If it could make a sound and light up.
It would be better. Yeah, it would be better.
That's really top tier.
What is your evolutionary goals? I want to talk and glow. That is agreed. Evolutionary goals. Okay, well, how does this work? Okay, so I'm going to go into the science without going too deep into the science. But really, there's still a lot of unknowns. The exact ins and outs of bioluminescence are not exactly known because almost every species does it differently, or at least every group of animals does it differently. But in general, it's a chemical reaction that happens inside the cells or ejected by the cells. So when inside of a cell, the molecules that can be located are usually inside a special, what's called a photophore organ, or more generalized. So it could be like, sometimes it's in, okay, think of like a lanternfish with a little glow bulb. That would be like a photophore organ. Or it could just be generally throughout the organism. And typically what happens is that there's a molecule called luciferin. And luciferin is the molecule that produces the light in the reaction. Luciferase is the catalyst. And a catalyst, of course, is something that speeds up a chemical reaction. Okay, so you need luciferase and luciferin both together. So luciferin plus oxygen made to happen with a catalyst, luciferase, and that equals light. Okay. Or it's luciferin plus oxygen plus a photoprotein, so a light protein, and then light. Or once you add in a specific element.
Yeah.
So a photoprotein is when a little protein that can do stuff with light is combined with luciferin and oxygen. It's a prepackaged thing. So it's like more efficient in an organism. So normally you've got this luciferin all over in their body, and then oxygen comes in, and then light. And if any of you are good with your Latin roots,
which you all know I am.
Yeah. So you might be like, luciferin, luciferase, why are they similar names? It's because Lucifer, if you think about Lucifer from the Bible, his name was that because his name meant light bringer. Luce means light, or lux means light in Latin. When the molecules mix together with oxygen, the reaction produces light, and that light can be red, blue, green, yellow, or violet. Most of the time, we see blue-green emitting organisms because they're in the water and the short wavelengths reach our eyes, or they're meant to communicate with animals that can only see in that light spectrum. So if you're underwater, you're really only using blue and green because honestly, it's only the only thing you can see down there, with exceptions. And then most terrestrial animals that are producing this light also do blue-green, but also tend to lean more towards yellow too. So think of lightning bugs, which I'll talk more about later. Different organisms have different types of luciferin molecules. So that's where things get different. Luciferin is just a catch-all term for this molecule that helps produce the light, but it might look different in different organisms. And other proteins can also be involved in this reaction depending on the organism. But what's cool about all of this is that normally when we think about light and reactions that make light, those reactions also make heat, right? Like the sun is bright and hot. Light bulbs, bright and hot. This reaction is considered a cold reaction, and they refer to it as a cold light because the only discharge from this chemical reaction is light, not heat. So none of the little guys are getting overheated when this is happening. So that's the molecules involved. Now, whether or not they glow is typically dependent on the oxygen part, right? So if oxygen is what they have to add to make this reaction happen, then if they can control how much or how little oxygen is allowed into the cell, that's whether they glow or not. So many can control when and to what degree and even what color the light is based on how much oxygen is going in or out of the cell or what other proteins are involved. Some are even multicolored, but that's super rare for an organism to be able to do multiple different colors. And where do these molecules come from that are even in their little bodies? Some make them just on their own, especially if you're thinking bacteria and things like that, because obviously that's lowest down on the food chain. But others get those molecules from eating the guys lower down on the food chain. So there's a really cool examples of symbiotic relationships with fish or siphonophores, which we've talked about on the podcast before, which are kind of like a jelly, but not quite.
Yeah.
There's a symbiotic relationship that they have with bioluminescent algae. So the algae are like, we need a safe place to live. And the organism is, I want to glow. So let's team up here. So the bioluminescent algae live in their gut, but the organism itself is see-through. So they glow because of the bacteria that are just healthily living inside of them.
Yeah.
Which is kind of interesting and cool. So that's bioluminescence. That's how it works. Luciferin, oxygen, catalyst, light, for the most part.
Yeah. Okay. Perfect. All right. Then, as Laura said at the beginning here, then I'm going to talk about offense a bit, and then Laura can talk about communication, and I'll talk about defense.
Sure.
So I'm just going to give some different examples of why the animals would be using this, and then specific examples of particular species.
Cool.
Because that's really the cool part. Yeah, then that's the cool part.
It's interesting to know how it works, but also, like, why bother? Why bother glowing?
Yeah. Yeah. So when you think of light, you probably associate it with safety, guidance, and warmth, as most people would, especially if it's in darkness. Well, I mean, you would, though. It would be like, oh, this is a safe place. This is something good. Yeah.
Exactly. Like in Finding Dory. We were just talking about this in Finding Nemo.
That's going to be my example. Right? Yeah, that's going to be my example here. Warmth. Yep. And so that's my first one is the anglerfish. And that's for offense, the luring of the prey. Right. So that is, I would say, one of the most iconic examples, I think, of people. If you're thinking of, bioluminescence, an animal that glows, it's going to lure in a prey. Boom, anglerfish.
Anglerfish. If you've ever seen Finding Nemo, perfect.
Yep. It's the one, I see a light. And then that's what it starts with. What do you see? I see a light. So,
and then things go south real quick.
Real quick, right? So the anglerfish is a classic example of offense designed specifically to lure prey rather than ward off predators. Unlike defensive bioluminescence, which I'll talk about here in a bit, or which often serves to disorient or evade, the anglerfish's glowing lure acts as an irresistibly deceptive beacon in the dark depths, drawing prey right to the fish's jaws.
There's not even moths down there, but same thing. They're like,
they just
show a light, something's gonna come for it.
This is amazing. So living in pitch black environments of mostly the Atlantic and Antarctic oceans, where food is very scarce, the anglerfish relies on the small bioluminescence lure that dangles from a modified spine on its head, positioned strategically above its mouth. And again, like we said, if you've ever seen Finding Nemo, that whole scene, go watch it if you haven't.
Yeah, where have you been?
Yeah, where have you been? Because it's so good. So this appendage emits a faint, pulsating glow that mimics the appearance of a small edible creature. In an environment where even the smallest glimmer is unusual and attention-grabbing, this tiny glow becomes a beacon of basically somebody just being like, oh my gosh, I'm so excited. Like, either this is going to be something. Like, I could eat this probably.
It's so crazy that this works because you'd think that in a place that's pitch dark, I feel like the chances are 50-50. It's either food or it's going to eat you. But everything down there is just dumb enough to not remember. Oh, yeah. Sometimes the light can be dangerous.
Have no clue. So the anglerfish has transformed the glow into a deadly trap. But as unsuspecting prey swims closer, captivated by the rare sight, it's entirely unaware of the massive jaws lying in wait just behind the lure. In an instant, the anglerfish snaps forward, truly with incredible speed, because things down there generally move fairly slow, but not this thing. And it closes its jaws around the prey in a super fast strike. This offensive use of bioluminescence takes advantage of the deep sea environment's limited visibility, using light not to hide, but to weaponize in the darkness, transforming an unlikely beacon into a lethal snare. So this tactic definitely highlights how the offensive bioluminescence can turn the ocean's darkness into a tool for ambush.
Cool. That's really metal sounding.
Right? It is pretty cool. More metal bands should use an anglerfish.
Yeah, they should. I actually it's crazy that we bring up anglerfish. I mean, not that crazy because of bioluminescence, but crazy in that I just talked about an anglerfish with Alora yesterday. No, wait, Wednesday. Because we saw a picture of one on a hat that was the logo of a brewery.
Okay.
And I was like, oh, look, that's anglerfish, like on Finding Nemo. And then she was like, oh, yeah. And then,
Another form of offense is mimicry and deception. The anglerfish, they're not the only ones using light to their advantage. Some predators take bioluminescence a step further through mimicry and deception. Certain species of predatory worms, for example, use
Ugh.
bioluminescence to mimic light signals of their prey, which is so mean. Like,
That gives me the
yes.
willies. I just got the shivers thinking about predatory worms.
Ugh.
Don't like that one bit.
No. So this one's called the railroad worm. It's a predatory larva of beetles.
Oh, I saw a picture of this.
Yeah.
While I'm looking up
it's
stuff.
in the genus Philthorax. I don't know. Was evolved.
Latin.
Yeah, something Latin. Evolved a unique form of bioluminescent mimicry that serves to lure prey directly into its grasp, making it a master offensive bioluminescent tactics, which is similar to the anglerfish. So, native to the humid forests of South and Central America, the railroad worm resembles a miniature train, hence its name, as it moves through the leaf litter with rows of bioluminescent green lights running down its side and bright red glowing at its head. This striking display isn't just for camouflage or evasion, it's carefully crafted deception. The green light mimics the ambient glow that many nocturnal insects associate with food or potential mates, effectively tricking them into approaching. Which, again, so mean. So the rare ability to produce both green and red, like Laura went into that, it's very rare to do multiple. But it's two separate things. So it's not like one area can go green or red.
Right. It's
green,
sectional.
Yeah, so it's green on its sides and then red on the head. But this allows the railroad worm to differentiate its glow from other bioluminescent species in its habitat, making its signal distinct and more likely to attract unsuspecting insects. This mimicry-based offense is highly effective in low-light environment where any glimmer is likely to draw attention. Insects approaching the glow see what they perceive to be food source or a mate, only to find themselves within striking distance of a hungry predator. Which, again,
unfortunate.
So mean. There's another tactic that they can use for offense, and it can be used to confuse and disorient prey. Known as an alarm jelly, quote unquote, that's what its nickname is. For its vivid, pulsating display, the Atolla jellyfish uses its mesmerizing light to show not just to evade, but to capture prey. Native to the Atlantic and Pacific deep water oceans, Atolla jellyfish create basically a circular display of bright blue light along the edges of the bell, emitting pulsing rings that radiate to the darkness. To unsuspecting fish or other small creatures, this rapid burst of light is confusing and distracting, capturing their attention and momentarily blinding them in the otherwise pitch black environment, because it is pretty bright. The jellyfish, meanwhile, hovers nearby, ready to capture anything that becomes disoriented in the glowing frenzy that it created.
Just a flashbang under the ocean.
Basically.
And then it's just like, I'm everything that's stunned.
Yeah, right. A similar tactic is used offensively by the vampire squid, which I know we've talked about vampire squids before. This releases a cloud of bioluminescence particles from the tips of its arms. In the still dark waters, these particles basically are just like a glitter cloud.
Yeah.
And it
a glitter bomb under the water.
Light. Yeah.
It just spits out light everywhere.
I'm gonna draw that one. A vampire squid with a glitter bomb.
And then it murders everything within said glitter bomb. I'm like, jeez.
I mean, it works. It causes them, again, to stumble into the squid's range. This glowing, like, quote unquote, ink is like the easiest way to describe it. Serves more as just an escape mechanism. For a well-faced predator, it becomes an attractive and active distraction, making it difficult for prey to tell it from foe. So you think of like squids and inking. That's most squids that'll give off like that ink and then they flee. Well, vampire squid, they use that bioluminescence and then they use it as attack. One more for offense here. Finally, there are creatures that use bioluminescence as a form of camouflage, which I know sounds defensive, but just hang in here with me for a second. Blending with the faint light of their surroundings to hide from prey. The lanternfish, which I think Laura you mentioned earlier, showcases how counter illumination can turn from simple camouflage into offensive hunting tactic. So, equipped with rows of photophores, like Laura was saying, along their bellies, lanternfish emit a faint blue-green glow that perfectly matches the dim light filtering down from above. So, I know we've talked about in other episodes the counter shading with animals. Like, that's why, like, killer whales are black on top, white on bottom, because anything that's from the bottom looking up, you're going to see white. And so, the white belly of a killer whale blends in. Anything above it looking down isn't going to see it because it's, the seafloor is black. Them emitting that blue-green on their bellies, that mimicry of ambient light essentially basically erases their shadow and makes them as pure as though it's nothing. Just nothing's there, which is pretty neat.
No shadow, but which is hilarious because it's the opposite of that. You know what I mean? Like,
no, right? Yeah, like it has light, so it's giving something, but it doesn't give itself like an outline because then you can't see what it is. Like you see lines. Yeah, you see the glow, but you don't actually see what it is.
Cool.
So that's offense in a nutshell. Yeah. So you want to go over communication then, Laura?
Yeah. So communication is the earliest form of communication on Earth. At least within the ocean, which is where life started. So definitely on Earth. So the earliest form of communication in the ocean was this bioluminescence, and it was thought to arise about 540 million years ago. And whether or not this was the OG reason for bioluminescence, I think it depends on the species because, like I said, it's developed over 40 times. But communication is definitely probably one of the earlier ones. And then things like offense and defense have come along because it's all kind of forms of communication, right? Because offense, they're communicating something.
Yes.
But I wanted to do something that is besides communicating, come hither and go away.
So, more true communication.
Right.
Yeah.
So I just have three different things for communication. One, identification. Bioluminescence helps members of the same species to be able to identify each other. Two, it can communicate to the same species if they found prey in the area. I only found one example of this, but dragonfish, cool freaking name, for another fish that's in the deep ocean, they use bioluminescence to create a red light in the deep sea, which allows them to see red-colored prey and communicate with other dragonfish like, yo, there's prey over here. And this is really unique because if you remember what I was talking about, the different colors that bioluminescence can create, red is never one of them. Very rarely. And that is because most animals, especially the one in the ocean, like you were talking about the railroad worm that lives, that's a terrestrial worm. Or a terrestrial beetle larva. The dragonfish are deep ocean. Nothing can see red light down there except for these dragonfish. They have developed a way to see red light, which is very hard when those wavelengths are typically blocked under the water. So others can't see this red light that they produce. So nobody runs away. Meanwhile, the dragonfish are all like, woo, 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 blinking to each other. Prey party over here.
Yeah.
And then the most exciting form of communication is, of course, mating. And a lot of the organisms use this bioluminescence for mating.
I mean, I can't blame them. That'd be pretty cool.
If you glow, you've definitely taken it up a notch.
Yeah, right. If he wanted to, he would.
Yes. Hence glow sticks at a rave, right? Yeah. Like the more glow bracelets, the better. Yeah. Not that I've ever been to a rave, but I would definitely be more attracted to someone who was wearing lots more glow bracelets.
Justin, take notes.
You want to be flashy? Glow bracelets from wrist to elbow. Mesmerizing. So recent research has showed that fish that use bioluminescence for communication diversified into more different species than those that didn't. Okay, so let's break that down. A lot of deep ocean fish are using this bioluminescence. Some are just using it for camouflage, which I'm sure you're going to talk about more with defense.
Mm-hmm.
But the fish that use it for defense, they have not turned into that many different species of fish, right? They have found their niche and they have went with it. Meanwhile, certain fish that are using bioluminescence to attract a mate, they're diversifying into many more species. And why is that significant? Because in the deep ocean, space is the biggest barrier to diversify, like to finding a mate, right? You're not divided by the scenery, by rivers, by mountains, nothing. The only thing that is preventing you from meeting your dream boat is the darkness and vastness of the ocean, which is significant. And how do you overcome that? Light.
I feel like there's some like bit, I don't know, deep, meaningful quote that just came out of that.
How do you find your dream boat? Light. Use your inner light. So those that are finding it, basically this equates to you produce light, easier to find a mate, you diversify into more different kinds of fish. You've beaten it. It is proven that bioluminescence helps find mates in the ocean because that's the biggest barrier. But when we think about like bioluminescent animals that try and find mates, if you're not thinking about anglerfish with bioluminescence, chances are the thing you're thinking about is fireflies because we're on land. So we see mostly things that glow on land, and that's fireflies. That's the big one. So preface this though with saying that not all fireflies flash. They're just called that because the majority of them do. Those that do are the more recently evolved of the species, of the different varieties. So what are the fireflies doing to make this so successful? So they can control when the chemical reaction within their bodies stops and starts. Remember, I said this whole key to all of that was oxygen. They have teeny tiny muscles in their little firefly abdomens that can let in oxygen when they relax or contract, one of the two. And they're letting oxygen in. So starts it and then stops it, and then starts it and then stops it. But their tiny little muscles just aren't that super fast because they're very, very small.
Yeah.
So to make them be able to flash faster and more often, they rely on nitric oxide gas, which, hilarious. I only included this because it is the same gas that is produced when taking Viagra.
Interesting.
Right? I don't know who, but I mean, I hope that whoever invented Viagra was like, the fireflies, let's do what they're doing. Probably not. Could just be a coincidence. I don't know. But the results are similar. Maybe, right? So their muscles, it helps theirs not to be hard longer. Theirs is to be able to contract faster or something, so that they can flash faster. Okay, so now that they've got the flashing part down, now they're using their unique flash patterns that show who they are to each other, and it shows the species and it shows the sex of the firefly. So most males fly around and are the ones blinking, while females just sit and wait and watch the sky. The ladies are all down on the grass, looking up, trying to figure out who's who up there, flashing around, and what they're trying to say. And fireflies are very, very particular in how they go about all of this to be able to identify who's who. So if you want to be like, okay, there's lots of flashing going on. What's my kind of firefly? I am looking at, are the males flying at the right height? Are they in the right habitat? And is it the right time of day? If I can figure out that, then I know what kind of species is flying around. So usually it is a male trying to do his little thing exactly right to attract the same species of lady. And then once they do, if the lady likes what she sees, she signals and guides him down with her flashing display. However, some chicks out there, some of these female fireflies are tricky. And if they're like, you know what? I don't like anything I see from my own men. Let's choose somebody different. They will mimic a different species to bring a dude down. If it's like, well, if none of my own are doing it for me, I'll just choose somebody else. So she will interbreed with a completely different species if she likes what she sees that they're doing better, which is pretty true.
So then there are crossbreeds out there?
I guess so. Or maybe they do it, but it doesn't result in anything.
Yeah.
But she's thirsty and she's willing to catfish.
Right.
And I couldn't figure out how to summarize this without just reading it. So I'm just going to read this this quote from this scientist, which I thought was fascinating. So according to Clyde Sorensen, a professor of entomology at North Carolina State University, a good example of these very specific interactions is done by a backyard species of firefly called the Big Dipper. So a male, which is also a cute name for a species, the Big Dipper fireflies.
Right.
A male flies around at dusk about 3 feet off the ground, and every 5 seconds or so, he makes 1 second flash. So he's going to flash, 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 and then every 5 seconds he does flash, flash. And he makes, as he flies in a J shape. Okay. So he is coming out 3 feet off the ground at dusk, flashing in a specific pattern, flying in little J's. And then the female, she's in the vegetation. If she sees what she likes, she waits 2 seconds before making a half a second flash of her own on the 3rd second. So this is like very much like Morse code or like semaphore.
Yeah,
you know, they're just using their little butts. Most species do flash independently, like of each other. So they're all competing against each other. But there are 2 southern species where the males will synchronize their lights together. There's like a species in the Smoky Mountains of Tennessee that people travel all over to come see.
Yeah.
Because it is just pulsing, glowing light because they're all doing it at the same time. I would love to see it. And that's how those guys are using bioluminescence for communication.
That's cool. Lightning bugs, we don't have as many down here in Texas. Is what we did.
We don't have as many up here anymore either, which is a real shame. But
yeah, they're going away, unfortunately.
All those lawn chemicals.
Right? Jeez Louise. Killing one of the coolest things out there. All right. So then last thing we're going to talk about then real quick is the defense. And
I love that you left this for last. We're like, lame. Defense.
Yeah, just lame. Defense. Dude, but offense is so much cooler. Like
this tells you so much about Katy's personality. Listen, if I'm going to glow, I'm going on the offense.
I'm going to kill. Yeah,
and I'm like, let's communicate here. And then finally we're like, okay, and if you must, defense, you can protect yourself with it.
Alrighty. So again, like I said, it's not always about standing out. In some cases, you need to just blend in so that you can virtually disappear. So we're going to talk about a few different examples here real quick. So we already briefly talked about counter illumination. And so we're going to talk about that again. But this time, this one is more on the defense, not the offense of
they're not trying to
other
trick.
ones.
They're just trying to hide.
Yeah, they're just trying to hide. So we're going to talk real quick about there's a deep sea shrimp actually that use this. And it is a certain species of deep sea shrimp. It's, again, so many things don't have actual names. Sergestes similis.
All right.
My closest guess. They employ counter illumination not for offense, like we already talked about, but as a highly effective defense mechanism. This adaptation allows these shrimp to remain concealed from predators lurking below, creating a stealthy advantage that enhances their chances of survival in a harsh environment where exposure can be deadly. Yep. Counter illumination, we've already talked about, works as a form of camouflage by using bioluminescent organs, like we already said, photophores, using the shrimp's underbellies. They emit a soft blue-green glow, which we've talked about, that matches the faint light filtering down above, just like, what was it, the lanternfish? Yeah, that I talked about?
Yeah.
So for a predator gazing upwards, that ambient light merges seamlessly with the shrimp's emitted light, rendering the shrimp pretty much invisible from the background.
Like, oh, it's just starlight filtering down through. Or bioluminescent bacteria.
Yeah, and they have no idea.
That's just shrimp running around. This is kind of sad. Like, it's all the predators at the bottom. They're just thinking they're seeing shooting stars all the time, and they're making so many wishes.
Beautiful. Yeah.
I just wish I could eat.
It's just shrimp.
And really, it's food the whole time.
Yeah. I just wish I had a next meal to provide for my family, and it's right there in front of their face. like it's right there. All their wishes could come true if they would just go
You
look.
can tell that Katy and I are both are fans of predators more than prey. But they're poor families.
Oh, goodness. So again, the light shrimp, it perfectly matches the natural light, cloaking its outline and making it blend seamlessly. By diffusing their glow to mirror the ocean's light, the shrimp essentially vanish into their environment.
I'm just thinking to myself, okay, there are some animals out there where I can see why there would be no common name because nobody would know and not that many people would care. But we are talking about bioluminescent shrimp, and I think that any animal that has put forth the effort to glow should have a common name, especially because it could be so cool. So today, right now, these are called twinkler shrimp. Like, for sure.
Yes.
Twinkler shrimp.
Okay,
Like, how could it not be called that?
Twinkler shrimp, yeah. I don't know how we get that.
I don't know, but just for throwing it out there,
recognized.
And all of our listeners, we're going to talk about them to each other and to everyone we know as twinkler shrimp.
Twinkler shrimp. Twinkler shrimp.
Right? Isn't that the perfect name for any kind of shrimp in general?
It is. Twinkler
shrimp.
Just a little twinkler shrimp. So counter-illumination is just one of the many ways organisms use bioluminescence for defense. Consider there's another one known as the green bomber worm.
Whoa.
Which is scientific
name. That sounds
name.
like offense, but it's defense.
It's defense. This is kind of okay. So this scientific name is Swimma bomaviridae.
All right.
But Swimma. I'm like, of course. SWIMA. Swimma.
It's just somebody from Australia talking about them,
right? Native to deep waters, this worm has developed a remarkable defensive mechanism. When disturbed, it releases small glowing sacs that emit bright green light. These glowing quote-unquote bombs startle predators, to which are momentarily distracted by the sudden flash, giving the worm time to escape. So we talked about other examples.
Yes, another flashbang, but this one is to get away.
Yeah, the other flashbang was flashbang, I'm going to come eat you. This is flashbang, now I'm running.
It is crazy. Can you imagine also, so we're talking about all these flashbangs, right? You got predators flashbanging prey and prey flashbanging predators. Meanwhile, you just have the innocent bystanders of the deep ocean who are just minding their own business and constantly being blinded. This is like when you're in your bedroom at night and like traffic comes by and just like if you live in the city. Oh crap, the neighbors are getting flashbanged again. Or you live in a bad neighborhood and there's constantly raids. Just damn, another flashbang. Somebody got eaten or somebody's dead. I don't know who.
I didn't think of it that way. Like it's like a little the other little fish around. Oh, someone got eaten again. Like,
did you hear about that? Like 6 anemones over. Flashbang again. Like just it's the bad side of the reef.
Such a good example. That's such a good example. 6 anemones over.
I'm glad I could be here for you.
My sides hurt.
My cheeks hurt.
Goodness. Oh goodness.
Well, I just like the word flashbang. And like I don't play Call of Duty that much, but whenever we would just be chucking flashbangs everywhere. It wouldn't matter if they were effective or not. You just go flashbang and yell it and throw. Right. And so I'm just imagining like if I had that capability to just use
in
my
real
own
life,
flashbang, like you just throwing them around everywhere. And then all these little just bystander fish just like every once in a while. But it would be dead silent. Just dead silent too, right? Just explosions happening around you, but in dead silence.
Yeah, because if that were to happen on land, you would hear like leaves rustling away. But there's just nothing. So
or like you think about like when a flashbang happens, it's also like a concussion sound, and you hear that like like in video games, it's like the sound, like the sound. Meanwhile,
nothing
in the crushing void. There is blasts of light happening, death all around.
And the only fear is like
silence.
But so it's all in your head. Like all the panic is in your mind.
No screams, just silence. Oh my gosh. The deep sea just got even more terrifying for me. I already didn't want to go down there, but this sounds 1,000 times worse.
I mean, if you were a tiny predator, like a tiny prey fish.
The twinkler shrimp are so much braver than I thought.
Yeah. Oh, goodness. So, no, I can't. Not that I was that I can't ever think of a green bomber worm in the same way. I've never thought about a green bomber in my life.
But they had a name at the very least.
Right? Oh, goodness. So there's another organism. It's a type of sea cucumber, which, again, scientific name because it doesn't really have just a common name. Phenastis eczema. Close enough. They use bioluminescence as a warning signal. So when threatened, the sea cucumber emits a bright glow, serving as an advertisement of basically saying, like, I'm toxic.
Which is crazy because everything else glows to, like, I'm food, right? Like, this is a very backfiring glow, I think. Right? Like, what makes their glow any different than the anglerfish who's like, please eat this glow? And this is like, don't.
A backfiring glow.
Also, great band name. Backfiring glow. Well, I'm just thinking, amazing. If anybody's ever seen a cute sea cucumber, you know, this thing already is like the most phallic shaped you could possibly imagine. Yeah, right. And then it's just a pulsing glow because it doesn't want to be eaten. Like,
yeah. Opposite effect, my man.
Yeah. Oh, a delicious ocean pickle. And then it glows. If it were me, I'd be like, now I'm definitely eating it. A glowing pickle? I can't think of anything more fun. I'm gonna pee my pants.
I have actual tears. A glowing pickle. I can't think of anything that'd be more fun.
This is 1,000 times funnier too, knowing that you're the plastic white girl. So, like, that literally would be our reaction. Would be like,
which I have
a glowing pickle. Just like totally freaking stoked for such a thing.
The picture that Laura sent me, like, what was 2 years ago now? Whatever that episode was.
Yeah, or maybe even 3.
Yeah, gosh. Classic white girl. Which I have converted. I am a full Best Made pickle girl now.
Best Made pickle girl. But
that's our local pickle company.
Absolutely gobble a glowing pickle.
Oh my god, yeah. Yes. We have way more fun in the dark. I mean, it would be
taking notes. He's taking notes.
Oh, goodness. Oh, my side hurts so bad. I'm laughing so hard. Oh, man. Well, it does have a form of warning coloration, similar to the bright colors of toxic animals on land. So I think that's where it thinks it's going anyway. If it's like
I'll mimic toxic land animals. Am I on the land? Nope, but it works for them.
I'm in the sea. Let's figure out if this works. I mean, I guess evolution has to start somewhere.
Yeah, it must.
You know what I mean? And this is like where a sea cucumber is going. Is like I don't know what else to do. Let's give this a try. Everything else keeps eating me. Like let's just go
like
with
a cucumber,
right? Oh goodness. There's other fish, brown snout spookfish. They take bioluminescence defense a step further by employing false eyes, and this happens like throughout other species that you can actually see. But again, this is a deep sea fish that has bioluminescent spots near its rear tail that resembles eyes, tricking predators into aiming basically for the wrong end. And again, this happens with like butterflies and all kinds of things.
A lot.
Yeah. And so this just has to be false eyes that glow because it's under a deep ocean. You can't see anything.
Yeah, it doesn't know where the eyes are normally.
No, right? Yeah, right. Yeah, true. Yeah, I can't see anyway. Another remarkable example comes from the Stalatheus sorrentius which is a deep sea octopus with bioluminescent suckers on its arms.
Oh, that looks cool.
Yeah, so when faced with a threat, it flashes these glowing suckers, creating a blinding display that disorients the predators, again with the flashbang.
Freaking cool.
Just long enough for the octopus to make a hasty escape. Which, again, it's more like a flash dazzle.
That's what I was just thinking. It's definitely more of like a razzle dazzle situation.
Yeah.
Where it's just putting its tentacles out and it's
That's
like,
another one I gotta draw.
yeah. Little razzle dazzle to get away.
Yeah. I imagine it does that and then like scoots out of the picture, like out of frame.
Definitely has to be like a side scooch. As it, it's like the predator comes over and it's like a little song and dance, like just to get out of the way. The predator's like, all right, fair enough. That was pretty good.
That was pretty good. Yeah, A++ performance here. So just go ahead and shimmy away now. But lastly, another squid, the Hawaiian bobtail squid, demonstrates.
And this is our squid biologist studied these.
Yep. So they demonstrate, and that was, what was it called?
Dr. Sarah McNulty.
Yeah, I was trying to think of the episode. Something squiddy.
Oh, yeah, something squiddy.
Anyway, if you go and you search squiddy in our Wildly Curious, it'll come up. But they demonstrate a fascinating form of bioluminescence camouflage because it forms a symbiotic relationship with bioluminescent bacteria that produce light to match basically the moonlit water above. And by eliminating the subtle glow, the squid again erases its silhouette, hiding from the predators below. So that's all I have I say that's all I had for defense, but man, did that turned out. That took
That was enough. That was enough.
Yeah, it took a turn we weren't expecting. Oh, goodness. Well, everyone, please support us on Patreon so we can keep bringing you glowing pickle content. It really does help Laura and I to keep doing this because there are fees and stuff with all this. And so far, even though Laura and I are bringing in money for advertising, our whole $1.70,
baby.
Yeah, right.
We're rich.
Yeah, Laura and I split in 50-50. We both made 88 cents so far, which is fantastic. I mean, it's better than nothing, but still.
Yeah. We're living the dream, making money on what we're doing.
Yeah, right? So anyway, support us on Patreon. It's a huge help. And then you guys will hear from us next week with another episode.
Your guess is as good as ours.
Which makes it exciting.
We live on the edge.
Right? Till next time, guys. Bye.
See ya.